Hi, I'm Mike from Craft Supplies USA, and today we've got an exciting video for you. We're going to be turning a matching set of CrushGrind mills. CrushGrind mills are some of my favorite mills to turn because they have a closed end, meaning we've got a lot more design options for the top of our mill rather than being stuck with the adjustment knob on the top where you always have to shape to it. And with that stopper design being just a spring collar on here, I can shorten this length depending on however short I want to make my mills. I can keep the pepper and salt the exact same height. Usually I'll make the pepper and salt a little bit different size just so it's an obvious visual difference when you go to use them rather than coloring them to have the contrast. So let's talk about the mechanism for just a second. So we've got an aluminum rod here, that way it doesn't corrode with salt or pepper. And the mechanism components down here, it's going to be all ceramic. And you can put salt or pepper or a combination of both, whatever you want, inside here. And you've got a really good coarse adjustment knob on the bottom. So we can go extremely coarse for our peppers, for dry rubs, things like that. And we can go really, really fine with this for your salt. Sometimes it's easy to put too much salt on things, but we can go really, really fine with that salt adjustment. And another thing about this too is these are designed and manufactured in Denmark, and they come with a 25-year guarantee. So very long lasting life. This is kind of an heirloom set of mills. You know, this is something that you'll have probably the rest of your life. So one of the great things about these CrushGrind mills too is that they're available in two sizes. This one's gonna be the 10-inch, and that's end to end. And when you put this in a finished mill, it's gonna be roughly about 11 to 12 inches long. So we come in a 10-inch or an 18-inch. And my favorite thing about these two is the stopper on the top here is adjustable. So basically turn your mill to whatever length you want it, and then you can just trim this to fit. That way you don't have to cut it and rethread it for the adjustment knob on the top. You can just trim this, you know, let's say you turned your mill a little bit too short because of a defect up here. So you shortened it by an inch, you just trim that off, cut away the excess, and it's a lot more adaptable and adjustable for your shape and size. One of my favorite things about turning a nice matching set of salt and pepper mills is when you turn a nice matching salad bowl out of the same material. That makes a great kitchen set and is one of the best gifts that at least I've given out for people, and I've got really good feedback from. So if you're selling these at a craft market, if you turn a set of mills with a matching salad bowl out of the same material, chances are that's gonna sell pretty quick. So talked a lot about the mills. Let's start turning. Let's get over to the lathe to show you the tips and tricks along the way, and we're gonna have a great time. So let's get over there. All right, so now that we're at the lathe, let's get our blank mounted up between centers, and the first thing that we need to do is rough this to round, get this to where we have no flat spots on here. Then we'll throw our tenons where we need them so we can remount the blank to drill it from both ends. And let's get this mounted between centers. You can see I already have each end marked here. And this is a little bit smaller blank than I'd normally start out with. This is just under 2.5 inches square. Ideally, I'd start with a 3, that way I've got a little more leeway for shape. But let's get this mounted between centers. And while you put this on your lathe, see if there's a side that you want the top to be or the bottom to be, depending on the grain. I think this looks about 6s either way. It's fairly straight grained. No particular figure on either end. And this oak is gonna look so good when it's done. I'm so excited to see what this looks like. And if you're wondering what these dark spots on our blank here, this is just different dye sampling. I wanted to see which color I liked better. See if I wanted to go black to make it look like bog oak, or if I want to do this rich brown to make it look more like an antique oak. So make sure we're mounted between centers. We're going to snug this down nice and secure, but not too tight. We don't want to put a bunch of tension on our bearings that we don't need. A lot of times guys tend to crank their tailstock down way too tight for what they need to do, and that's just going to cause your revolving centers to wear out faster and put more load on your headstock bearings as well. And we'll be roughing this out with a skew. You can use whatever tool you want to start out with. If you want to use a spindle roughing gouge, great choice. I'll be using the skew. The only thing I need to be careful with on the skew is because this is so open pored, as we get underneath that end grain, it's going to tend to lift the fibers. So once we start getting this closer to round, we'll have to take lighter cuts, make sure we get a really, really clean surface, but this will give us a clean cut, and our tools are nice and sharp as well. All right, so I'm just going to move some of these extra tools off to the end here, and I've got my tool rest set. You can see it's a little bit above center because we want to be at that 10 to 11 o'clock position when we're using our skew for those planing cuts. And again, just make sure our cutting edge is at a 45 in relationship to the oncoming wood. So as this piece is spinning around, we want our cutting edge to be at that roughly 45 degree as that comes across onto our cutting edge. So if you haven't learned how to use a skew yet, we've got a great video on that. We can link it down in the description below, get you started with your skew. Again, safety glasses, dust protection. Oak is known as an allergy or an irritant to a lot of people, so if you are allergic to oak and that's what you're going to be turning, I would always recommend wearing a dust mask. Make sure you have dust collection going. So it might get a little dusty in here because our dust collection in the studio is not great, but let's make sure everything's snugged down nice and tight, and then we'll start this at 0 and bring this up to speed. Initial roughing while we still have the square corners on, about 1700 RPM. And we're going to start just taking the corners off nice and gentle. You can see as that cutting edge gets underneath those end grain fibers, especially on these square corners, it lifts them up pretty bad. So we want to take fairly delicate cuts until we get these big corners knocked off. See, we're getting some big flakes as we get under those fibers. Bring our rest in now that we've got a pretty big gap between the rest and our workpiece. We want our cutting edge to be supported as close to the tool rest and the wood as possible. So always bring that in when you need to. And now that we've got those big corners out of the way, we'll bump this up to about 2200 RPM. Still just some little flat spots. If we stop the lathe, you can see we're getting close to round, but we still have just some of these flat spots right here. And you can see as it's lifting those end grain fibers on those really aggressive cuts, it's definitely tearing that fiber out. But as I take a lighter cut, we're getting a nice clean cut on that oak. So now that we're getting close to round, I'm just going to take a little bit lighter of a cut. I want to make sure we're getting that good shearing plane and we're leaving a super smooth surface behind. And you can see the feed rate, how quickly I'm advancing the tool across the workpiece, slows down just a little bit. I'm not pushing through super fast and tearing those fibers out. We're taking just a nice controlled cut across the surface of our piece here, allowing those fibers to be cut and lifted out of the way and leaving a really nice surface behind. So by increasing our turning speed and slowing down our feed rate, we're going to get a lot cleaner surface. And we're still good about that 11 to 10 o'clock position with our cutting edge. And we're at that 45-degree angle, bevel riding cut, shearing plane, great surface. So let's keep getting this round. We're almost there. I've got just a little bit of a flat spot right here. And because this blank is a little bit smaller than I normally start out with, I have to make sure I stop turning as soon as this gets to round because I want to maximize the diameter down here at the base so we can match this mill that I've already turned. And this one's pretty close. We're maybe 1/8 of an inch difference in diameter between our rough blank here and this finished piece. So it's handy to start out with a larger diameter blank. That way you do have more room and a little more wiggle room in play if you do have any tear out that you have to cut through. So we want to make sure as we're starting to get this close to round, we have a nice clean surface. So now that we're pretty close down on this right side of our blank, I'm going to do just a really light cleanup pass. If we start hearing that chatter, that means we're pushing too hard on the bevel. So I'll do this on the rounds, but if I push too hard on the bevel, that's the sound we get. So if it starts chattering at you and moaning and groaning, that means, hey, you got to just back off the bevel pressure. We just want to float that bevel. We don't want to push it in, push the wood out of the way. We want it just skimming across the surface of the wood. Just try and straighten this blank out just a little bit. This is unnecessary because as we remount this piece in our chuck, it's going to be just a little bit out of round. So that's close enough for what we need. So let's grab our mill that's finished and let's lay out the overall length for the body and then for the head. And the great thing about these mills too is this is listed as a 10-inch mill, but once you have your top mounted on there and you have a little bit of extra room below the grinder, you can make this, you know, a 13-inch mill, a 12-inch mill, however long you want to make it, depending on your shape and things. But if you also, you know, have a catch or something and you have to shorten the overall length, you can adjust that just by cutting the rod. So that's the great thing, is you do have a lot of escape room essentially by being able to adjust the length of this rod, and because you don't have the threaded cap on the end. So if you need to shorten it or anything like that, that's easy to do. So that's one of the reasons I like this mill. It gives me a lot more room to work with the piece, so I don't have to rethread my rod like the other ones and then cut them down and things like that. But this is going to be the bottom of our mill here. This is going to be the top. Let's grab our finished mill and just eyeball this. And if you want to make this an exact matching set, you can. I'm going to give myself about a 1/16 of an inch here that I have to true up on the end. Make sure that I have a nice square surface, if anything slightly undercut, that way it sits nice and flat on our table. And just to make sure I've got enough room there to get rid of the wax, get rid of any tear out, get a clean surface. So we'll go basically 1/16 or so, and then this is going to be our shoulder. That's going to be the transition there between this nice curve and our half bead. And then I've got about an 1/8 inch wide bead here. And then this is going to be, if I can hold this still, this is going to be the end of our mill here. I just hold my pencil on the piece and rotate it by hand. And we're going to make these as close as we can. If you're doing production style where you have to have exact matching sets, I would probably build a template or something that I could use to just lay against the piece and it would mark it for me. Or if you have something like Richard Finley does where he's got little fingers that drop once he gets to a certain diameter, that's a great way of doing it. But we're just doing a kind of a one-off matching set here, so being exactly perfect is not too critical. And if you screw something up to where it won't be able to match, then you just do a totally different shape so they don't look like they're supposed to match. So this is going to be where we're going to part off the head from the body. We've got our small bead there. This is going to be our bead transition, and then we've got the nice straight section there. And you can see here, with this oak, the biggest thing is making sure we get super clean cuts, so that way we don't have any tear out we have to deal with, and you'll have just a super smooth mill. And the end grain on oak is one of my favorite woods out there, but just a gorgeous mill, especially once we get that nice dark chocolate dye on there. I think that's going to be a really good matching set to have a pepper and salt mill. And one of the other things too to consider is a lot of times, let's say this is my finished pepper mill. Generally the salt mill is going to be a shorter mill. So let's say this is about 12 inches. I would probably turn a 9 or a 10-inch mill for a salt mill. That way you've got varying sizes if you're not going to dye it to have a visual color difference as well. All right, so now that we have our mill dimensions roughly laid out here, the next steps are going to be cleaning up the end grain fibers here for our base, then throwing a tenon up here on the top, then creating a groove and another tenon here so we can remount this to drill those bigger step bits through the mill body. So I'm going to start down here and cleaning up these end grain fibers, getting rid of the wax. We'll start out with a peel cut and then we'll go to a slice to just get some clean cut fibers. Slightly concave is better than having that be convex. If it's convex, it's not going to sit flat on the outside of the foot. So we want to make sure that we get that slightly concave, if anything, or perfectly straight. Now that we got rid of the wax and the surface is trued up, let's go to a slice, and we'll just get ourselves a little bit cleaner surface here. Now let's move this over here and do the same thing on the headstock end, and we'll throw a tenon on here for our chuck. Just getting rid of all that wax. Get our nice tenon profile. And we'll do a slice just to slightly undercut this so we're sitting nice and flat on our chuck jaws. Now we'll go to a narrow parting tool. I want to use a narrow parting tool so the grain aligns when the head and the body meet back up together. I want to remove as little material here as possible so that way the grain does match, at least to some degree. I don't want to have a good ½ inch, or a ¼ inch gap here. And then I'm going to step it down just to give myself a little bit extra clearance. I'll go to my smaller skew to cut the tenon. And if you need to, we don't need all this material here, so we can part that down just a little bit to give ourselves room for our skew. Just going to cut those peeled fibers off, and then we'll do a nice slicing cut. Throw a small chamfer on my tenon here. Throw another one there, just couple little extra practice cuts. Now that we got these surfaces cleaned up, we have our tenons that we need to remount for drilling. Let's go ahead and finish parting this off. Then we can take these two pieces off, throw our chuck on, and mount this in the chuck so we can start drilling. I'm going to drop that speed down just a little bit. Take a little bit of that tailstock tension off so as soon as I cut through, I don't have a bunch of tailstock pressure that pushes this in and kind of collapses on itself. And then we'll just catch these pieces by hand. We're going to catch one of them by hand. But now that we have our top here, we've got a nice tenon on it so we can remount that. And then this is ready to remount into our chuck. And I've left this center here. Normally I'd part that and clean the entire end grain surface off as much as I could to the center. But I want to keep this here so when I remount that in the chuck, I can bring the center up, make sure this is running nice and true so that way, I'm not 1/8 of an inch out of round because I don't have the material to retrue this. It'll be much smaller than that other mill. So let's get our center out here. We'll throw our chuck on and get this remounted. All right, for my chuck, I'm going to be using the VM120 with the shark jaws. This is my favorite set of jaws, are the shark jaws, because it's essentially just a regular dovetail jaw, but I do have the extra length to give myself more room away from the chuck body, which is really handy. So we'll make sure we seat that up, and then we can throw this in the jaws. So I'm just going to lightly hold that, and then I'll bring up my center, make sure this piece is running true, give that just a little bit of tailstock pressure, and then we'll snug this down. And you want a really good working hold with your chuck as we drill this, and especially on those longer mills. If you're using the 18-inch CrushGrind, you're going to be drilling through a really long body. We want as much support as possible, and I'd probably make that tenon about twice as long as this one is here, but I don't want to have a super long tenon on this end for this diameter piece that I have. So make sure that we're running true. We can turn this on real quick, just make sure, yeah, we're running dead true. If it's not mounted upright, you're going to have this thing be wobbling out around, and you'll have to true it up again. So now that we have this trued up, let's get our tool rest set up so we can square off the end of the blank and start drilling. All right, so now that we have this mounted in our chuck, we need to square up the end of this blank, get that ready for drilling, and we want to make sure that we have a really good center point that's running true. If your piece shifted and it's not running true anymore, the second you go to drill that in there, the Forstner bit's going to pull that blank to center, and then the whole thing's going to be crooked in your chuck jaws. So we'll peel cut this with the center in place as small as we can get. Then we'll get our revolving center out of the way and finish cleaning up the end of this with some very, very light, delicate cuts, because we have a fairly short tenon, about 1/4 inch long, but we have a lot of leverage with this long of a blank, especially on the longer mills. So we want to keep our center engaged as much as possible, give us the support we need for that cut, and then we'll get it out of our way at the very end. So I'm going to use my 1/2 inch skew here to peel cut this as small as possible, making sure I don't hit my cutting edge on the threaded section of my center, because that will just munch my cutting edge there, screw it up. So I'll bring my tool rest as close as we can to get this supported, and we'll do a couple of V cuts just to get rid of this material. I want to be nice and delicate here if we're using a cut that's too aggressive, trying to remove too much material. We could probably possibly pull this out of the chuck or cause it to not run true anymore. There we go. And we need this surface to be as flat as we can get it. That way the Forstner bit finds its center point and drills a nice accurate hole. So we also want to create a small little chamfer here, small little center point for our Forstner bit. Okay, we're going to move our tool rest out of our way, and let's throw in our keyless chuck and get the drill bits we need. And for this kit, for this mill in particular, you're going to need 1 3/4 inch, a 1 9/16, an 1 1/16, and then a 15/16 for the knob end here. So 4 different bits. If you don't have those exact bits, you could use ones that are a little bit smaller, then use a scraper to open the hole up to the size you need. So that's always an option. All right, so I've got my bits. We're going to start out with that 1 3/4. Want to make sure that we get this keyless chuck or your drill chuck seated nice and well. A lot of times I've gone to start drilling and this wasn't seated accurately, so it started skipping around. So we want to make sure that's seated nice and well, and then we'll bring this up to speed. Our drilling speed is going to be right around 500 RPM, but I'm going to keep my tailstock loose, so it's not tight right now, but I'll advance the drill bit till it engages and finds its natural center point, and then we'll lock that down and we can start drilling. And this is going to be fairly noisy, so I'll stop talking as we drill. But the biggest thing is we want to make sure that we clear the chips frequently. That way we don't get chips jamming up in there and it starts smoking on us. And we want to make sure our drilling speed is at 500 RPM or a little bit below. The drill depth on this bit is going to be 3/4 of an inch. All right, and typically on my mills, I'll drill this about 1/8 inch deeper than the 3/4 inch measurement that we recommend. I like having that grinder mechanism recessed into the body just a little bit further. It's not going to affect the overall function or fit. You might need to shorten the rod by, 1/8 of an inch, whatever you add. So if you do add a drill depth to this, make sure you note that in the overall length. But I like to have that recessed in there just a little bit further. You can use the ruler on the quill, or if you have calipers, I like to just double check my depth with this to be 100%. So I'm going to set this to 7/8 just to make sure I get the depth that I need, or 13/16 to 7/8. All right, looks like I've got about a 1/16 to go. I'm going to go just a touch deeper. And again, you'll have to account for that in the overall length of your project. So at the very end of this video, when we get it all together, I'll give you the measurements of mine and see what modifications I made to the rod, or if I didn't have to make any at all. But the measurements are more of a guideline, depending on the aesthetic, and if you want to shorten it or go with the longer mill, obviously, will be different measurements as well. So. Okay, that's going to be good for the 1 3/4 bit. Now we'll go to the 1 9/16. And I'll bring this up to where it's engaging the teeth, and then I'll check where I'm at on my ruler on the quill. So we're just rubbing there, and this one, so from where we're at now, we need to drill 1.5 inches deep. So I'm basically 3/8 here, so I'll keep an eye on that as we drill. So the ruler on my quill should say about 2 1/8 for our overall depth. When you're drilling, make sure your bits are nice and sharp, that way they don't burn the surface. And they cut a cleaner hole as well. If you have an air compressor, it's nice to blow that out, get those shavings out of the way. All right, we're about 1 3/4 inches, about to 2. We're gonna go 2 1/8 inch deep. Got about 1/8 of an inch left to go. Let's just clear our shavings. Before we drill too deep, let's just double check our holes with our calipers. Our overall between these two should be 2.5. Let's set our calipers to 2.5. Check our depth. If you have a tape measure, another quick way of checking. Okay, we are right at 2.5. I'm gonna go just ever so slightly, a little bit deeper, make sure that I've got the depth I need. All right, now we can switch this out to our smaller bit. And this smaller bit, we're gonna need an extension to get in there far enough. And we're gonna be drilling this. With the extension, we're gonna be drilling it about 3/4 of the way, basically to where this line is. That's as far as I wanna drill. And then I'm gonna switch to a smaller bit and drill the rest of the way from this end. And the reason being, if I grab the mill mechanism, so in our instructions, we call out drilling this with a 1 1/16 hole, and that leaves a 1/16 inch gap basically, because this is right at 1 inch in diameter. And if we put this in an 1 1/16 hole, it has more slop than I personally like between the knob and the body, and I don't want these things to be able to shimmy too much. I want a really, not a tight fit because it'll be hard to spin, but I want it to be where there's basically a slip fit to where those two surfaces are contacting but not binding, and I think that leads to a higher quality mill. So I'll be drilling this out with a 1 inch on this end rather than drilling this all the way through with an 1 1/16. So you don't have to do it the way I'm doing it if you don't want to, obviously, but I like to have a little bit tighter fit between this stopper piece and the body of the mill. So I'll drill that with a 1 inch from this end, but let's use the 1 1/16 to drill that most of the way through. And if you wanted to, I know Mike Mahoney does it, he'll hollow out the inside of his mill in the body section here to give himself more volume so he can hold more salt and pepper. But I'm not gonna do that on this guy here. So let's use our bit with the extension. Back the quill out as much as we can so we have as much travel as possible. Make sure that keyless chuck's snug down nice and tight. And then we'll keep drilling. And before I keep drilling, one thing that most people don't talk about is why we always drill from largest to smallest. And the reason being, if I drilled this initially with the 1 1/16, then went to that 1 3/4 inch, you know, 3/4 of the bit doesn't have anything to register on, and it starts to skate around the surface because it's trying to engage the outer teeth and then it doesn't know where to go. It needs to engage on the very center point. That's why we always drill from the largest diameter and then we step it down. So if you ever want to experiment with that, just get a scrap piece, drill a 1 inch hole in it, and then grab a bigger bit and try drilling, and it'll skate around on the surface and it doesn't run as true. So we always want to start with the biggest bit and then end with the smallest. When you're backing the drill bit out, make sure you don't back this out so it self-ejects the quill while this is still in the blank. That's happened, and it's pretty scary because it happens fairly fast. So make sure you stop backing the quill up before it'll eject itself. All right, so we're basically up to the keyless chuck for our drill depth. So we're right about to that line. That's gonna be good enough and we can finish drilling from the other side. The good thing about doing that is that's gonna minimize drill bit wander. If you're using wood that has a lot of figure in it or a really dull bit, a lot of times, because there's so much flex and leverage in this thing, it tends to wander over time and it'll cause your piece to not be running true once we remount it. So drill it halfway if you need to, flip it around and then drill it the rest of the way. And usually those holes will be pretty much right in line. So Let's get rid of this drill bit, get this out of our way. We'll clean up the end of this here, sand it, because we won't have much access to this area once we flip it around, and then we can remount this and finish drilling. All right, so I'm looking at the end grain fibers here. We got those cut really clean with that slicing cut from the skew, so those are ready to sand. I'll lightly sand the inside of this because that Forstner bit did tear out the fibers pretty good, and I want this to look a little bit nicer. So we'll just sand that a little bit. We'll sand this end here, and then we'll flip the piece around. Whenever you're sanding, make sure you use a nice dust mask, respirator. I will actually throw a small chamfer here on the inside edge of the mill. I was just thinking about that. I think it would look nice with just a little bit of a chamfer. So I'll use that skew. We'll just cut a small little chamfer here. Just soften that edge. Sanding speed for the lathe, we're about 1100 RPM. Nice and slow. We don't want to sand at 2000 plus. Sandpaper doesn't really actually work that well, and it just ruins the paper too fast. That end grain oak just looks so pretty. All right, now let's take this out of our chuck and we'll flip it around, and we will switch jaws. But you can see we've got nice clean drilled holes, nice clean foot here on the bottom of our mill. All right, I'm going to switch this to my VM100. This has the extended pin jaws. This allows me to get inside the drill hole and expand into it to hold it while we finish drilling. And then once we finish the drilling, we'll use our revolving center to support this end as we get the body to our shape that we want. All right, with this oak having a lot of tannins inside the fibers of the wood, anytime we rest that against metal directly on the wood surface, it's going to darken and discolor. And I don't want to have the foot of this pepper mill resting on this for any length of time. If I left that on there overnight, the bottom of this would probably be black in the morning. So just to help keep that from getting discolored, I'm just going to throw a little bit of paper towel on here. I'm not worried about the inside of the drilled hole getting discolored, but the foot of this, because we're going to be throwing dye on it, I don't want to have that blackened from being in contact with the metal. So I'm just going to throw some paper towel on the bottom side there. So I'll expand that to where it's a little bit snug but not too tight. And then let's just turn this on low speed, make sure we're running true. It's got ever so slightly out of wobble, but that's actually really well mounted. A lot of times, if your bit wanders at all and you go to remount on that, this thing's pretty much out of round. So we want this to be running as true as possible. We'll pull off the extra paper towels. We'll save those for some finishing. And then now that we know we're running true, we can just go ahead and expand this just a little bit tighter to give us a good working fit. We don't want to overexpand it, especially with this oak where it's all drilled out. If we crank down on this, we're just going to split our mill body. So snug enough to turn, but not too tight. All right, for this top hole for the stopper on our mill, I'm going to go with a 1-inch bit. Instructions say 1 1/16 that we used on the inside. I'm going to go with a 1 inch so it's a little bit tighter fit here, and we'll try it out. If your bit's running super accurate and it drills a really clean hole, it might be a tight fit with this stopper that you'll have to open up, but let's drill it out and we'll see exactly what kind of fit we have with our stopper. And before I drill, I want to make sure the surface is nice and clean. I've got a lot of tear out from parting that off, so I want to make sure that surface is clean cut and we have a good center point for that bit to register and find center. Get rid of that nub. Now we'll throw a small little chamfer on the inside, a little cone. And we don't have as good of a hold on these expansion jaws because we can't get super tight, and we don't have a dovetail keeping it retained in the chuck jaws. So you have to be even more delicate than we were before. All right, let's drop our speed down for drilling. 400 or 500 RPM. Keep the tailstock loose, advance your bit. You can see that drill bit pulled it off center just ever so slightly. It's just at 1 or 2 degrees off true now. It's still running true enough back here that we're not going to lose diameter. and this is going to neck down a lot anyway, so I'm not too concerned about that. If you can true it up a little bit, that's good, but right now that's not too critical. But I'm going to keep that tailstock nice and loose so the bit gets our natural center point, and then we're going to lock it down. As you get through that initial 1/8 inch or so material, go nice and slow so that bit doesn't start to wander, because it gets exponentially worse the further we go in. I'm just going to snug up the quill locking lever to get rid of any play in the quill. If this is totally loose, it allows that bit to move around side to side and get pushed around by the wood. All right, that's running nice and true. Let's drill this to where we meet up with that other hole. All right, we've drilled through. All right, let's check the fit of our stopper now with that smaller size bit. And that's just a little snug. So that's ideal. If it's a little bit too tight to go in and we just open that up with a little bit of sandpaper, we might just have a little bit of a burr or some torn fiber from our Forstner bit. Let's try sanding that out with some 320 just lightly. It's very easy to over sand things, so I'd rather start out with a little bit coarser grit. That's close. But yeah, I want a nice snug fit, otherwise that thing wobbles between the knob and the body of our mill. So let's go ahead and sand this out just a little bit more. Let's check that fit one more time. Perfect. So it's not tight, but it's not loose. That's ideal. Just going to sand a little bit further in that drilled hole. I don't want a bunch of torn fibers snagging on the peppercorns or your salt, whatever you're going to put in there. And then let's just clean up this surface here, because once we start turning this and shaping it, we're going to want our revolving center or our cone center here. And if we try and square this surface up with a cone center there, we're going to have a small little ridge, obviously, because you're not going to want to hit your cone center with your tool. So let's just clean up this surface down here, right up against where the inside of the drilled hole is going to be. And we'll get our revolving center prepped as well. All right, let's do one more slicing cut here to clean up these end grain fibers. And again, we don't have a very good hold with our chuck jaws right now because there's nothing keeping them on there. No tenon, no dovetail. Very delicate, easy cut. Getting a little bit of chatter. And then again, ease those fibers off right towards the inside of the drilled hole. All right, that surface looks good. I'm going to throw a small chamfer on that inside edge as well, because we did get some curled fibers. Nice, gentle scrape. Okay, now this inner surface touching by the revolving center is nice and clean, so we don't have to worry about cutting through that later. Let's get our tool rest set up to start shaping the body. And now at this point too, now that we're done drilling, I'm going to bring this off of the face of those chuck jaws a little bit, because we're centering off of our drilled hole with a revolving center. I don't need the foot registration up against the chuck jaws to help keep this running square. We can bring this back ever so slightly. That way I can still do some planing cuts here, throw a small chamfer, and sand this without hitting our chuck jaws. And this surface pretty much won't change at all. We'll just start adding our decorative details that we marked on here, and then we'll just make sure that this is just nice and lightly snug, and this should be running nice and true. Ever so slightly out around on this end, but that's okay. We've got our decorative bead right there. If we grab our mill, and we're trying to replicate here, this is how we have those marked lines. All right, so if I overlay the mill that we're trying to match, our bead section looks like it's right about on the money. If I just hold these right on the end there. Our beads need to come to my left about a 1/16 of an inch, and same with this line. So I'm going to create a new line, bring our tool rest up, bring this over slightly. And this is a new style of mill shape that I haven't turned before. So I'm still trying to figure out what I like for the style and the shaping aspects. But once you nail a style that you really, really like, then you can start building kind of different fixtures or jigs, things to start replicating that shape faster. But this shape I'm still kind of playing with, because normally I'm so used to turning the other mill where it has the adjustable knob on the top, and I know what my shape is and I know the dimensions, so I don't really have to measure it. It's just kind of by eye. So playing around with this, and we'll see if we can get this to match almost the same or identically, if possible. But let's go ahead and start shaping this. So we've got tailstock support. We're on our chuck jaws. We're not too tight for fear of splitting the blank. I do need to reduce the diameter of this down a little bit. The diameter right here is about 2 7/16. You can see we're still not all the way down around the outer diameter. So we'll do a few planing cuts here just to clean this up, get that to size. Then we'll start shaping the bead, getting our dimensions here, and then we'll start shaping the neck out towards the top of our mill. So I'll be using the skew for some planing cuts here. I want nice, clean surfaces. So I'll bring that tool rest up so my cutting edge is right about that 10, 11 o'clock position. It's nice too because we had a little extra material so we could true up our surfaces. Slow down as you get towards the end of those chuck jaws. A few more planing cuts and we should be to our diameter. I'm actually going to grab my parting tool. Just going to part down my step here so I don't lose it. All right, so as I was doing that planing cut there, I could hear a little bit of a ticking noise. And a lot of times if you have a crack in a piece, it'll make that same kind of ticking noise as it skips across the surface. But there's a teeny little like bug hole or something in the surface there. And so what we can do is I'm just gonna get some of the shavings off the floor and fill that in with some of the dust and use thin CA glue just ever so slightly just to bond those little dust fibers, because I don't want to saturate the entire surface. And then we'll use that, kind of spread it around with some more of the shavings. Hit it with a little bit of activator and just kind of build that up to hopefully fill in and hide that little wormhole or whatever that is. I'm using the extra shavings just to wick away any excess CA glue, because I don't want to have a big CA glue spot on there that prevents any of my future finish from drying or penetrating into the surface. A lot of times you'll fill in certain spots with CA glue and then you'll put your finish on there, and then there's a different discoloration area of where the CA was because it doesn't allow the finish to penetrate, or the dye. So we'll just let that cure for just a second. Now let's go back and let's check these with our calipers first. A couple more planing cuts. We might actually be able to cut through that bug hole, but we'll see. As I get towards those chuck jaws, I just ease the fibers off and I don't force it through the wood. All right, so it's fitting over that little groove I've got there. I'm gonna set another step down because that's what with the surface height that we need to plane to. Okay, now let's get our shoulder to our half round. So I use a parting tool to part that down. And I don't know if you can see this on camera, but I'm parting inside of my edge that I want for my overall length here. That way I can use the skew to get in there and get a nice slicing cut and clean up the end grain fibers. I don't want to part right up against my finished width here. I want to part just on the inside of that so I have enough material to clean that up with a slicing cut. Switch hands, make sure that bevel is nice and straight in line. I can see I'm going to hit my skew on this high section here. So let's go ahead and V-cut some of this material out of our way. Okay, and if you raise any of the fibers right here, just come back with a nice little plane. Just to clean up the surface. Use my parting tool to get our overall width. Okay, now let's start shaping the body of this. Once we get some of this material out of our way, then we can start getting the half round down here. But we do need to get a lot of this material out of our way to do that. So we've got a nice clean cut face on the end grain fiber. This is all to our diameter that we need, and we have a nice clean surface. That'll send out super easy at 320, and we've got a nice clean foot there. I do want to add one little decorative element. Decorative element here, we'll throw a nice little chamfer with a slice. I think that's going to give it just a little extra added detail there. Also, having a slight chamfer on there helps prevent dings and dents on this very bottom foot here. So let's start planing this, getting this rough shaped. We can see, obviously, we're gonna have our detail bead here, but let's start getting a nice convex form here, nice shape, flowing curves. Something that looks nice when it's sitting on your counter. A little bit of noise, added just a little bit more pressure with my tailstock. I think it was working loose a little bit with the handle here. So we'll do some planing cuts, get rid of material. Just going to set the apex of that curve, just eyeballing it there. Just needed to true that surface up. I'm going to reset that apex, just so I have a frame of reference of where I need the curve to start changing. I think it's about time to go to the grinder and sharpen this skew. I can feel I'm having to push a fair bit harder than I should. That shape's coming out nice though, I think. It's a little heavy right there on the apex. I think we need to bring that down just a little bit because it's about in line with the overall diameter of this. I think those need to be about the same. I checked that with my calipers, obviously that's still too heavy. So we'll just bring that down a little bit, remark that apex. Let's go sharpen our skews real quick though. And that'll help us get a cleaner cut as well on this oak. It's looking good though, I'm really happy with that shape. I'm excited to see what this looks like once we get some dye on here as well. All right, so we got these sharpened up here. let's start taking a look at that half round. All right, for this little half round here, I'm gonna go to my spindle gouge, start getting the shape that I want. Just gonna use my parting tool to get this bead roughed out. That's our overall position of the bead. And that bead isn't very tall, it's about a 1/16 of an inch. So we'll keep necking this area of that down. All right, so now that we have our shape and all of this established, let's keep parting this down. So the diameter right here at the smallest size, that's gonna be the outside diameter of that bead. So I'm gonna part on the outside edge of this to establish the depth that we need for our bead and where the neck is gonna go down to. And we'll part on this side of the bead. It's roughly that same size. Got just a little bit of diameter I want to decrease right here as well. I want to get a nice flowing pass down to our diameter that we just established with our parting tool. I'm going to part some of this down just to give myself clearance. True up this surface as well. And we will be incorporating this tenon here into our overall length, so we don't want to get rid of that yet. We'll be keeping that. Take a look at your form. I think I've got a little bit of a high spot there. Otherwise, that curve's looking pretty good. Let's establish that bead, get that set, get that rounded over, and then we can start getting our last few planing cuts in shape on this side of the bead to our bead. Anytime I'm forming a bead, I like to set the apex so I know exactly where the high point needs to be, and that's going to be right in the center. And then everything else is going to be removing material on each side of that line. That puppy needs a sharpening so bad. All right, let's see what we can do with a nice sharp tool here. There we go. When I was rolling that bead on that left side, there was just so much resistance to the cut, and there shouldn't have been. Same thing when I was removing the bulk here. I was having to push way too hard. And it still wasn't cutting. All right, that side looks good. Now that we have that bead established, let's get our overall diameter of the top here. We'll set that with our calipers and check it against what we have on our blank already. So we're going to be about 1/8 of an inch smaller than this tenon diameter. So I'm just going to peel cut this all down, get this to the same diameter. All right, just a little bit to go. We'll do some planing cuts to get a cleaner surface, and then we can start coving that out and getting our shape. Nice clean surface. Now we can start coving this. We'll throw that chamfer on there we have so we know our overall height. Using the long point to get in there and get a nice crisp transition from the bead. All right, we're getting really, really close. I'm really happy with the shape we've got here. I do need to cove this out a little bit more on this side of the bead and then flatten this section and have a little tighter radius in that cove. So I'm not going to touch this area here. That's all really well clean cut. I'm going to pick up the cut here though. Try and get as clean of a surface off the tool that we can get. We'll use the heel of that skew to get in there up against that bead. Now we just need to flatten this area out just a touch. Trying to take the lightest shaving possible. Now we'll go back to my spindle gouge just to cove this out ever so slightly. All right, I'm really happy with that curve. I like the rest of this. This all matches really well with what we already have turned. The last thing I need to do on the body before we sand it is just do a nice slicing cut down to the revolving center to clean up those end grain fibers. That way we can get this sanded and then throw our die on. And we'll stop just as that cutting edge gets right up against the revolving center without touching it. So we've got nice clean cut end grain fibers there. Let's go ahead and get our tool rest out of the way. We'll get this piece sanded and then we'll be ready to apply some dye. All right, so before we start sanding, we're in the studio without a very good dust collection, so I will be wearing a mask while we sand. Biggest thing though is we want to make sure that we keep our speed nice and slow, 600-700 RPM. We don't want to overheat this and cause any heat checking, and we don't want to wear out our paper too fast. We'll start out with about 220. If that's not cutting this really dense wood very efficiently, we could drop down to 180. But we'll take a look. We've got a really clean cut surface. This doesn't look like it's been clean cut that well because you see these lines. That's just from bevel rub. That's not torn fiber. This is all super clean cut fiber. We're just looking to smooth out any curves and any imperfections from our tool control. So let's go ahead and sand this. Once we're done sanding it, I'll pull the mask off and then we'll keep talking. All right, so you can see these little radial scratches. We've sanded through 320. Let's sand with the grain to try and get rid of those, because once we put the die on there, it's gonna soak deeper into those little scratches, the little valleys, and show them, and it'll be a lot more apparent that there's scratches there. So let's just sand this with the grain. Try and get rid of those radial scratches, especially right here on the body and this flat section. You don't really notice that as much in areas with a cove or a bead, things like that, but on these long straight areas, let's go ahead and sand those scratches away. And be careful when you're sanding. We don't want to sand out the nice, fine, crisp detail that we put in. You know, this bead's really well shaped. If you had a 180 or 120 grit paper, as soon as you touch it, you're going to be putting flat spots on it. So I would say if you are going to sand the detail areas, or you need to sand them with a finer grit than you think you need to. That way you're not going to deform or misshape the nice detail you have. Or if you have really bad detail, use some really coarse paper, then you can make a bead look really nice. Okay, now that we're sanded at 320, I'm just gonna hit it with some Merlon non-woven abrasive, get it to a little bit finer grit, and then we can throw our die on and see just how rich and pretty this oak is once we get some dye. This non-woven abrasive, this stuff's 2500 grit. We also have it in a 1500 grit, but it just helps improve the surface, almost gives it a burnished look to it. And because it's non-woven, you don't really have a radial scratch pattern like you normally do with the paper, and it's a lot finer grit. This is the kind of stuff I like to sand detail areas with, because it's so fine it doesn't misshape any of my detail, and it doesn't dull a crisp edge like I have on these corners here. With this stuff as well, I like to sand this in reverse. I get a lot smoother surface that way. Anytime I do bowls, anything that you're going to be handling, not just looking at, I like to sand it in both directions. I get a lot smoother surface. But let's see how this looks just off that. So that's really pretty. Gorgeous grain structure. We got good shape. It matches almost identically to our other mill we've got right here. And we don't have any deep scratches or any torn grain, anything like that. Let's just blow this out, blow all the dust out of the open pores, and then we'll throw our die on. All right, so we've just blown all the dust out of this. Now this is ready for our die. So I'm gonna remount this back on our chuck jaws, and I'm gonna keep this fairly extended so I can get to the bottom here and get access to the lower part of our pepper mill. And then I'm just gonna lightly grip that. We're not really gonna be turning this at speed, and then we'll bring up our revolving center, make sure that's on center, and then we can move that away. Let's go ahead and throw our gloves on now. We don't wanna get this die on our hands. And we'll be using the Artisan Chocolate die. I think this color is going to be a really rich, nice, dark brown. And with this being oak, there's a lot of different surface treatments you can do to make this really pop. You can do fumed oak, where you put it in a container with ammonia, and then the ammonia vapors react with the wood and gives it a really rich look. I know Mahoney is really well known for doing that. Or we could do the steel wool and vinegar to darken it if we wanted a really dark black oak, make it look similar to the bog oak. But I think this rich, dark chocolate dye is going to make this really pop. So now that we have this on here, let's grab our rags. We need to shake this up. This is an alcohol-based dye. I don't want to be using a water-based dye raising the grain. So we'll use an alcohol-based dye, and this has a little bit of shellac content, so you need to make sure you mix it up real good, just shake it. And we'll create a nice little kind of a mouse pad here with our paper towel. One of the great things about this dye too is if this chocolate dye is too dark for your taste, you can dilute it down with alcohol to thin it out to give it just more of a wash color. Something not so dark and contrasting. But when we apply this, we want to make sure we get a nice even saturation of dye, especially in the open pores here. We want to make sure we put enough dye on that it goes down into the bottom of those open pores so we don't have a bunch of little white flaky areas that we didn't actually get the dye on. And the other thing too is, depending on what color you want to be on your piece, you know, if let's say this is just too dark for what you want for the rest of the mill. You can always just get a rag with just straight denatured alcohol and cut it back and remove some of that dye, and that's going to lighten it up quite a bit. We'll apply this down here on the bottom on the end grain fibers, and once we get the rest of the body completed, we'll take this off the chuck jaws and make sure we get inside the recess, that drilled hole. That way you have the same color all the way around. That way when you pick it up, you don't see a bunch of natural oak underneath. Just going to keep applying this, making sure to spin it by hand. That way we get a nice even saturation of our dye. But I think this color is going to look really, really good. And it's going to give us a really nice contrast to the natural mill, the natural oak, you know, for your salt and pepper. I think it's going to be a really pretty piece. Once this is all done, we get our final finish on here as well. The other great thing about the alcohol dyes is they dry extremely fast. You don't have to wait for that water to evaporate like a lot of water-based stains and dyes. As far as the application here with the rag, the reason I never pour the dye just straight on the piece is generally you'll oversaturate an area and it'll always stay darker than the rest of the piece that you're rubbing and applying the dye on with the rag. So, especially on the figured areas, because it'll soak into the end grain fibers much deeper than the side grain fibers. So I like to have a fairly even application with the rag. I think this is looking really, really good. This reminds me of something you'd see like on a 17th century English, you know, warship or something like that, with oak handrails and things like that. I think this is a really pretty color. On the end grain here on the mill, I'm going to make sure I put a nice heavy coat on there, that way it soaks in nice and deep here. And we'll also get on the inside of this drilled hole as well. We'll bring up the revolving center, and I'm just going to give this a quick spin by hand, see if there's any areas I need to blend out or add more dye to. I think the main body here could use an extra little bit of dye. Doesn't seem as dark as the rest of the mill, so I'm just going to give this a good wipe down here with a little bit more. All right, with this being an alcohol-based dye, we want to make sure our dye rags, we've unfold these, let them sit out to air dry. That way we don't have a fire risk in our shop. So generally I'll just take these outside, sit them on the ground, let them dry out, and then toss them after a few hours. But now that we have the dye applied, bring up your revolving center. Let's turn the lathe on, and we're just going to buff dry this, kind of set the shellac that's in this dye, and then see if we can even it out and smooth out the dye we've applied. All right, let's stop the lathe and take a look here. Make sure we have a nice, even, consistent saturation of our dye, and it looks like we've got a really good application here. You can see how in the open port areas it's nice and darker, really makes the grain pop. The medullary rays here look really good as well. Really nice piece. I'm happy with the application. So let's take this off the lathe. We'll set it aside. We'll do our final application of our finish, which is going to be the tried and true varnish oil, a good satin, food safe finish. That's what we'll be putting on once we're done with the top as well. So we'll set this aside and we'll get our top on. We'll mount that in the chuck. We're going to drill this out for the stopper to fit into. This is going to fit into a drilled hole, and then we can turn it around and get the shape and match that up with our other mill. All right, now that we've got the mill body done, we're going to mount the mill head back into our chuck, and we have that tenon on there that we cut when we were initially roughing this blank out. So first thing we need to do is square the end of the blank up, add a small dimple for our drill bit, and this bit that we need for the stopper to fit in is going to be a 15/16. And we'll be drilling that 1¼ inch deep. If you, depending on the size of mill you're turning, if you're doing a taller knob for this, you could drill it deeper just to remove some weight internally, but we'll drill this 1¼ inch deep. So let's go ahead and use a slicing cut to clean this up and add our small dimple. Tool rest is a touch high. All right, let's see if we cut through those torn fibers from the parting tool. I think we're okay. We've got just a little bit of a tool mark there, but those fibers are fairly clean cut except for the center. So let's move our tool rest around. We'll create that small little dimple in the center. Just using this flat on the tool rest, using that long point to get in there, give us a small taper to help this bit find its center point. Let's bring this up and we're going to drop that speed down again for drilling. And then we'll bring this up till it finds its center point. And then we can lock our tailstock down. Again, if we tighten this up just a little bit where we can still move it back and forth, that's going to reduce some of the play in the quill. Using the ruler on my quill as a guide, we should be good on our depth. And we can just do a little test fit. And this should register right on that shoulder, so that's going to be perfect. And now that that's stuck in there, we're just going to leave this, and this is going to be our finished mill knob. There we go. All right, just check that with a straight edge, make sure that's slightly undercut. That way we don't have a gap between the body and the head. That looks good to me. Let's go ahead and sand it. We'll hit this with the Merlon, and while we're here, I'll grab my denatured alcohol and my die, and we'll just dye the bottom face of this, because once we mount this on our jam chuck, we're not going to be able to dye that surface. Hit that with some denatured alcohol, just get rid of any of that dust. Again, make that nice little pad there for your die. And then we'll just put this on while the lathe is running. And then we can finish buffing this in real quick. Make sure we get the nice even saturation to match the body. And we'll put just a little bit on the inside of that drill hole too, just so it looks nice. We'll let that dry for just a second. And then we're going to buff that again with a clean cloth. Just to help set the die. Okay, that looks great. So now that we've got the hole drilled, the face of this squared off, slightly undercut here, a little bit of a taper towards the center, and we've got our nice sanded finish surface with the die on it, it's time to mount this on a little bit of a jam chuck here. And if you have chuck jaws that fit inside that opening, go ahead and use those. Otherwise, you can just get a piece of scrap wood, turn a small spigot to fit inside the drilled hole. And we want that nice and tight because we're not going to be using our revolving center for support. So we want this to be a nice working fit, something that's going to hold it on there tight enough so we can actually turn and shape and sand this piece. And this one I did out of maple, that way I can reuse this. This is the one I used for the original mill. And do it out of a nice dense wood, that way you can reuse these over time and it doesn't compress the fibers to where it's a loose fit the next time you go to use it. You can see I've got my jaw marks marked here, so that way when I remount it in my chuck jaws, it's going to run nice and true. So I just marked the outside of the jaw, and this is jaw number 2 there. And when we remount this, I'll show you. The other thing you can do too when you're turning this jam chuck, get your calipers and set them for the diameter of your mill body that you need to turn to, and while you're turning the spigot, you can just match that and turn that to the exact size. So once this is remounted, you're just turning that mill head just down to the base of your jam chuck. So we'll find jaw number 2 here, and we'll just line up the outsides of the jaws with those marks I've put on the piece. And this should be running nice and true. Yep, runs good. This should fit tightly as well. And I've undercut this surface as well, so we're registering on the outside diameter. Nice snug fit. And we can twist it on as we go to help. Make sure we're seated up against the face there so this thing isn't running out of true. Looks like we're good there. And so I set my calipers for the outside diameter of the mill body where the head will meet, and it's just a little bit bigger diameter than my spigot here. So I'll be watching that as we shape it. And if you want to match, if you're going to be matching your pepper mills, have the piece that you have the pattern off of so we can watch our shape and try and match these up as close as possible. All right, so before we start shaping as well, I want to mention I've got my outside diameter is just a hair smaller than what this already is, so I don't need to mark that. But I've set my calipers for the overall height of this piece, and we're going to want to mark our overall height so that way we don't turn this to be too short. I'm going to turn to the outside of this line and then start working it back. That way I can fine tune my overall height, but that's going to give me my safe line there. And if I put our pencil on our tool rest, we can just give that a quick spin by hand. That way we can see it as the lathe is turning. So let's go ahead and start shaping this. Again, take your time. There's no need to be in a rush to shape this. All it takes is one cut to get this past to where they're gonna not match anymore. So I wanna get my apex as well. So this is gonna be the overall end of the blank. Basically the midway point is gonna be that apex of this curve here. And it's a gentle flowing curve to where it meets the body, but then we have a fairly tight, acute corner here, or a round for our top. A little bit of a heavy cut there. Let's go ahead and just remove some of this material. Because we have the extra length, I might actually just bring up my revolving center just to give us a little extra support as we do these heavier shaping cuts. And I want to be mindful of how far I press this revolving center into the piece. I don't want to push it in too far because we can obviously damage a lot of the fibers in this end grain, and this is a fairly sharp point on this revolving center. But that should give us just a little extra support as we do these heavier shaping cuts. All right, let's stop the lathe and take a look at our shape, see what we've got developing here. I think we're looking pretty good. Our overall length is about where we need it. Just a little bit proud of that, but once we get that rounded over, I think we'll be there. But I think we're still a little heavy on the top end here, and then just a little bit smaller towards the spigot or our jam chuck. We've also got a little bit of a flat spot there from this thing not being fully rounded, but we're getting a really clean surface off the skew on that end grain with that nice shearing planing cut to a slice. So let's keep up with that and we'll keep shaping it. I'm going to switch to a little bit smaller skew now, see if I can get a little bit better cut. Then just a little bit of chatter. Do a series of V-cuts here. I'm going to lower the rest again now that we're at that smaller diameter there. And we'll use the V-cuts to get this down to size, a little closer to the center. Actually, a little peel. The curve's good, it's just a little bit long, so we're gonna shorten that up. We'll pick up the cut midway. Got that smoother. Now that we're working back at that bigger diameter, I'm actually gonna bring that rest back up just slightly. What happens with the skew when we're really low, closer to center, it's a lot more, a little less control of a cut. I wanna either be above center or quite a bit above center. That helps you get that cut a little bit cleaner, a little easier to control as well. And as I'm shaping this, I'm watching the top of the blank, the horizon, seeing the shape that's developing. If I'm watching right at the cutting edge, generally I can't see exactly what shape I'm getting, but I think we're pretty close. Getting a good finish off the tool as well. I think the bottom half to our apex is looking really good. I think it's still just a little bit long. Let's double check with our calipers for our overall height. Yeah, we need to remove about 1/8 inch of material. So let's go ahead and get our overall height set, and then we can adjust the curve to it. And this is long point down. We can't remove a lot of material with these slicing cuts, but we do get a nice clean surface. All right, we should be pretty close to our overall height that we need. All right, that's right on the money. So now let's adjust the curve, remove some of this excess here on the corners, just a tad heavy. A few cuts should do it. Just to blend that curve, I think that looks really good. Now let's get this down to size. Again, we're working that smaller diameter there, so I will bring this over, or sorry, bring the rest down slightly so I'm not way above center, so I have to tip that handle really, really high. When I part this waist section off, I want to do it about 1/8 of an inch past where my finished surface is going to be. That way, if I do break any fibers, I'm not going to have tear out that's so deep. I have to change the shape or modify it to get rid of the tear out. Let's go ahead and get rid of our revolving center. All right, now to get our final shape here, I want to make sure that we do a nice clean cut. That way we have a really clean surface, we don't have to sand a lot. Switch to the smaller skew. I think that bigger skew is getting just a tad dull. Okay. Let's stop and compare. All right, I'm really happy with that shape. Let's go ahead and sand it, see if we can get that to match up exactly with our first mill. I'm gonna throw my dust mask on while we sand this. All right, that's looking really, really good. We got those curves blended well. Now let's just sand with the grain here, just to get rid of any of those radial scratches again, like we talked about, especially here on the end grain, because this is kind of the focal piece once people pick them up. All the end grain fibers here is just such a striking look, especially on this oak. We want to make sure we have as good a finish and sanded surface as we can get. Let's go ahead and hit with that with the Merlon now. And one thing about oak too is it's easy to over sand, where you sand those low areas or the softer areas, and then you have a kind of a ridged pattern. So we want to sand this nice and even. We don't want to be putting uneven pressures on here. It's going to cause that to sand the soft areas between the grain, and then you have a really textured piece. So now that that's sanded really good, let's go ahead and take this off the lathe. We'll blow it off, then we'll put it back on for just a second so we can throw our die on, and then we'll be ready to put this mill together and put our final finish on. All right, so we've blown this out, got all the dust out of these fibers. Let's just give it a wipe down here with some denatured alcohol again, just to get rid of any of the extra dust. And then we'll put some dye on here. All right, let's see how pretty all this end grain is with that nice curve with that dye. With the majority of this surface being end grain, make sure you apply plenty of dye so it saturates evenly. If you just go and put one coat on, it's going to soak in differently, and it's not going to be a nice even color throughout the end of this piece. Before we put the dye away, just make sure, inspect all the surfaces, make sure we have a nice clean blend across the entire piece. Inspect the surface, make sure we've got a nice even saturation of our dye. I think we're good with that. Let's go ahead and take our glove off. We'll dry this on the lathe, kind of buff dry it. Nice and low speed because I'm not really on the jam chuck still. Just enough on there to drive it, but not support it really, so be nice and light with your pressure. You can see we get a little bit of excess dye coming off on the rag, but this should be ready for a finish. Yeah, very even color saturation, and those striations going through this blank just looks so cool. Okay, let's get our lathe bed cleaned off. We'll grab our mills, we'll get them ready for finish. We'll show you how to apply that. We just need to clean off this surface first. All right, so we've got our mills ready to go, ready to put our finish on. We just put this out on the lathe, and the finish we're going to be using is the tried and true varnish oil. This is my go-to finish for most projects that I need in the kitchen that are going to be food safe, as well as the finish is very low fume, so I can do it in a studio or in my shop where I don't have very good ventilation and not die because of the fumes like traditional brush-on lacquers. But the great thing about this, super easy to apply. You apply it off the lathe. And what we need to do for the first coat, I do it just a little bit different than their recommended instructions for general woodworking, flatwork kind of stuff. I like to put a nice heavy coat on, let that saturate, penetrate as deep as it can get for about 10-15 minutes, up to an hour. Sometimes I'll leave it. And as it soaks in, you'll see dry areas across the piece where it's soaked in the finish, or areas where the finish is still on the surface. So I'll put that first coat on nice and heavy, let that penetrate, and in about an hour we'll come back in and we'll brush off any excess lacquer areas and just kind of brush those in, let it sit for another hour or two, and then we'll let that cure overnight. So generally speaking, for the amount of coats that I put on, I'll usually do 2 to 3, and that's about it. And then once it's fully cured for about 48 hours or so, I'll put on a top coat of just protective wax to help maintain the finish. And it's something that's nice. If you're selling a set of mills, you can always provide a small tin of, a mixed beeswax mineral oil kind of thing. That way, when a customer buys it and they use it for a long time, they can reapply a nice finish to help keep these looking their best. So for this first coat, I'm just going to create a small little pad, and we'll be applying this on fairly heavily. If you watch Tried and True's videos on their page, they go very, very thin, sparing levels or amounts of finish on their stuff, but that's generally for flat work kind of things. But I have a lot of end grain fibers here, and this is going to soak in a fair amount of this finish. And with this dark one, this is going to probably pull a little bit of that dye residue, so you're going to want to switch rags between the clear one and the dyed one. But you can see as we apply this, this just enhances the color we have on our piece and gives us a nice protective finish. And the great thing is too, is because it's food safe, we don't have to wear gloves, we don't have to wear respirators as we apply our finish, and it's got a nice pleasant smell. One of the other things I really like about this finish too is it does have a bit of a golden color to it, so it does enhance natural color in the wood. You put this on cherry, it's going to darken it to a really rich cherry color. Some finishes are too dark, and they just discolor and darken the pieces a lot more than the wood naturally looks with a good finish on it. So I like to go with something that's either neutral and clear or something with just a slight amber tint. And the other thing too is this is a very satin sheen once it's dry, and I really like the look of this stuff on my pieces. This finish, the tried and true, is a polymerizing boiled linseed oil essentially. And it's not like the linseed oil you get at your hardware store. That stuff has a horrible smell to it, and it never really fully dries. So this stuff's good because it will cure. It will skin over in the can if you leave the lid off long enough, or it's been sitting for years. Yeah, you can always buy the bigger jar here, throw it in a stop-loss bag, that way you don't lose any finish if you don't go through it very fast. But I tend to use this finish so often that I don't have it skin over. The end grain fiber areas, we want to put especially a heavier coat, because that's going to soak in more than the side grain will, just like it did with the dye. Putting finish on the knob top here where this is all end grain fiber, go extra heavy. This stuff's going to soak this in about 5-10 minutes. You won't even see any wet residue on the surface. So we'll make sure we get a nice even coat on this. And if you do pick up any dye on your rag and you're doing the dyed ones, make sure you switch it out so you don't discolor the natural colored one. Let that set. I'm just going to switch to a clean rag. Same thing with our dye. We want to make sure we let these dry out. Don't want to have these combusting in our shop. Actually, we'll just flip that over to a clean side here. That we don't let that finish go to waste. But you can see how that just enhances the natural color in that white oak. Makes it pop. Gives it a good, rich color and tone to the piece. Especially on the end grain fibers. It just looks so good. All right, so we've let these sit for about an hour, and you can see just how much finish they've soaked up. Some areas are still glossy where it's sitting on the surface. Everywhere else where it looks dry, that finish is soaked in nice and deep. So let's go ahead and put one more coat on, and we'll go another. This one's soaked in quite a bit, so I'll put another heavy coat on and then come back and check it in about half an hour or so, wipe off any excess finish, and then I'll let this sit overnight and let it cure. So let's go ahead and put on another coat. You want to make sure this mill is well protected for many years of use. All right, so we're going to set our rag out to dry. We'll let these sit for about a half an hour to an hour or so. Come back, see if there's any areas that have soaked up all that finish and that we need to reapply. So we'll be back in just a little bit. So that's going to be our second coat. This is a nice heavy coat. This is going to help also saturate and make sure we get complete coverage with the finish. And it's going to just add a little more protection as well. So I'll let this sit for about 30 minutes, come back and check, make sure that there's no other dry areas, and then we're just going to wipe away any excess. I don't want to leave this puddling on the surface because it'll polymerize, it'll cure on there, and it'll have a really thick, gummy finish. So we want to make sure we wipe off any excess resin before we let this cure for 24 hours. But we'll let this sit for about a half hour, and we'll come take a look at it. All right, so these mills are looking really good. They don't look like they're really absorbing much. So let's go ahead and wipe off the excess, and then we'll let this sit for about 24 hours. You can go a little longer if you want to, but we'll let this sit and dry overnight. And then tomorrow we'll come back in and we'll throw just a little bit of a paste wax on there just to help protect the wood a little bit over time. All right, that's looking really good. Let's set these over there and see how they look with the mill tops on. I think those mills look really, really good. I love the contrast between the light and the dark while still maintaining the same grain structure. I'm really excited to have these mills completed so I can use them, but let's let these sit for about 24 hours. We'll let the finish fully cure. Then we'll assemble them, throw our top coat of wax on, and then we'll be done with this video. All right, so we have our mills here. The finishes on these are nice and cured. So the finish looks really good, the finish is ready to go. Last thing we'll do is throw a little bit of top coat wax on these once they're assembled and ready to use. But the first thing we need to do is we need to talk about the installation of our mechanism into the body and the head of our mills. And on these mills in particular, they do have these little tabs, and we didn't talk about this in the turning process, but if you want to, you can cut a recess inside the body of the mechanism, or inside the mill body here, that these little tabs recess into, and they'll click into place so you don't have to epoxy or glue the mechanism into the wood. However, I don't generally do that. It's a lot more finicky when you're trying to cut the little groove in there, making sure that you get a nice snap fit and no play in the mill. And the other thing too is trying to get these out with those tabs once they're locked into that little channel. It's a pain in the butt to get these out. Where if I epoxy these with just a nice, fine coat on here, I can always pound this out. It'll ruin the mechanism getting it out, but at least it'll save the mill body, and I'm not going to damage it trying to get these tabs to unsnap. So, it's kind of up to you. If you want to cut a little recess in there, there's a small little tool you can cut the recess with, but I'll leave that up to you guys. I just generally don't do that. If we take a look here, this is the cutaway how this mechanism mounts into our body here. And you can see we've got those little shoulders that will register on the mechanism. And then the only gluing surfaces, if we take a look here, the only areas that we need to glue is just the very bottom shoulder right here in the corner, and then the shoulder here on the stopper piece. That's all we need to do to glue that in the body. And these have a fairly tight fit just putting them in by themselves because these are a squeeze friction tab. So when we press this in, there's actually a fairly significant amount of resistance just trying to get this into the drilled hole. And with just that light layer of epoxy down in that shoulder, that's going to hold this mill in place for years of use. So let's go ahead and get our epoxy ready to go. We're going to be using the Star Bond. This is just a 5-minute epoxy, so we don't have to wait a long time for it to cure. And the nice thing is it comes with a little silicone spatula and a little mixing tray so we can keep this nice and tidy. And once the epoxy cures, you can peel it off with the spatula and this little tray. All right, for this 5-minute epoxy kit, this is a 1-to-1 mix ratio, so equal parts. And we'll just put a nice, nickel-sized amount in our little mixing tray here. And we don't need a lot of epoxy. We've got a fairly tight friction fit with the way we drilled the holes nice and accurately. So we just need something to bond that little shoulder area to the body. That looks about right, 1-to-1 to me. Now let's go ahead and mix this up. And we want to make sure we mix this nice and thoroughly. Make sure you scrape the edges so you don't have areas of epoxy that aren't going to cure. We want to make sure that this has a nice even cure rate all the way across any surfaces. Little silicone spatula is really handy, and we shouldn't need a lot of epoxy for what we're going to be gluing in. And we'll start out with the stopper piece. So I'm just going to lightly coat the inside, first eighth of an inch or so, and then we'll put just a teeny little bit right here around the rim. And if you want to, the nice thing about using these epoxies, it gives you a little bit of working time to get the glue where you need it. And if you need to, go ahead and use a Q-tip, something like that, to help get the glue exactly where you want it. Now we'll just set that guy down there. Get our stopper piece. We'll just make sure that's seated nice and flush. Press it all the way in, and then if you do have a little bit of excess epoxy around your stopper, just grab a small paper towel and we can wipe this off. Keep that surface nice and tidy. So that's going to be the stopper. Now let's go ahead and do the mill. And we're just looking to get that epoxy right in the shoulder where the mill is actually going to be contacting and giving us our good fit. All right, we've got enough epoxy on the inside edge, and I'm just going to drop this down. And we'll press that into place. Make sure it's seated all the way up against that shoulder. And then we can grab the knob and we'll press that in as well. Because we're not using those tabs, we want to make sure once that knob's fully pressed down, press the mill in from the back end there, making sure everything's seated nice and tight. And then we'll just let this sit for 5-10 minutes, and that epoxy is going to cure. And before I actually use it and grind with it, I'll let that sit for just 24 hours, make sure that's fully set up, but that mill should be ready to use, and then we can throw our top coat of wax on. So let me just apply the, install the mill on this side. We'll get our glue in and get this one done as well. And once this stuff's all cured up, we'll come back a little bit, and then we'll get our top coat of wax on there and show how the grinding mechanism works and why you might want a crush grind instead of just a regular mill. All right, so we've let these sit, that epoxy's fully cured up, so now we can take the tops off and we can fill these with our peppercorn and our salt. So I want to show you the different aspects of this mill with the grinding mechanism and the adjustment, which is a really cool feature. But let's go ahead and let's fill these up first. And again, like we talked about during the turning process, if you had a little bit bigger blank and you wanted to hollow out the inside of this to hold more peppercorn, that's definitely something you could do. I'm going to fill this to about 1/4 inch below the surface of the end of the mill there, just so we have room for that stopper piece. All right, so now that we've got this together, let's talk about the adjustment, how to make a finer or a coarser grind with this mill. Most traditional ones have the threaded knob on the top that you use to raise or lower the grinding parts together to have a coarser grind or a finer grind. But the nice thing about these crush grinds is you just turn this little gray knob right here, and that's going to change how coarse of a grind you get. And because of the ceramic mill on both of these, you get a really fine grind if you want to, or we can back this all the way out and you'll see just how coarse of a pepper grind we get. So that's going to be great for your rubs, something if you're going to be throwing it on the smoker, and it grinds a lot of pepper really, really fast with fairly good ease. Some of the mills, it gets fairly stiff to grind them, but we can tighten this up as well and get a lot finer pepper grind too. So if we just move this stuff out of the way, that's kind of like a medium, and then if you tighten this all the way up, we can get a really fine pepper grind with this. So pretty big range of different coarseness adjustments with this mill, and the great thing is it has a really good warranty on their mechanisms as well. So let's go ahead and fill up our salt now. Now let's loosen this up and we'll show you the salt grind as well. Get a nice coarse salt, or we can tighten this up and get a really, really fine grind with the salt as well. But that ceramic mechanism grinds pepper and salt both extremely well with a fairly easy turn to grind it. So, all right, so now that these are filled up and ready to use, let's just throw a little bit of this wood butter on top. This is going to be a good protective wax top coating that if you're using these at your house, or if you're going to be selling these at a craft market or online, this is a nice little added item you can sell with your projects that the customers, whoever's the end user, can reapply this finish. If you need to wash your pepper mills if they get food or they get dirty, just being able to reapply a nice little easy top coat finish for customers is a good added value item. And this is just a nice little blend of oil and some beeswax. So it's going to give it a good smell as well. It's got a nice citrus scent to it. And this is one of my favorite top coat finishes, especially for boxes, where you say we have something with a lid on it. You don't want a finish that's got a lot of fumes that's going to be off-gassing a lot over time. Because every time you open up a box like that, it's going to smell just like the finish, like a jar of finish. So having something with that nice citrus finish or citrus smell to it is a nice thing to have. Once I get a nice liberal coat on there, I'm just going to buff it with a nice soft cloth like this microfiber. That's going to give it a little bit of extra water protection while it's in and around the kitchen. All right, so we have our pepper mills. They're done, they're completed. I'm going to be taking this set home Normally we leave these things here in the studio for photographs and things, but I think this set might disappear. But we've covered a lot of tips and tricks along the way. Hopefully you stuck around for the whole video to see how we assemble, how we do things differently than a lot of the other turners out there for their pepper mills. But it's just a really pretty matching set, and we've got a nice matching oak bowl to go along with it. So that would make a killer gift, or it would be great to sell as well. If you guys liked the video, go ahead and leave a thumbs up. Leave a comment down below for your other turners. If you have any good tips and tricks, tag us on social media if you've turned a set of CrushGrind mills. And as always, subscribe to our channel for more wood turning videos.